Good morning. When we last left you, we had just introduced to you to a few important electricity terms: current, resistance, and voltage. And today we're going to spend a little time just talking about what the relationship is and how that we can actually tie those measurements together mathematically. So, yes, we get to do a little math thanks to a guy by the name of George Ohm. Um, he put together a formula that described that relationship between these three things: current, resistance, and voltage, and how that they're going to mathematically be related. You see the formula listed for you there: V equals I times R. Voltage is equal to the current times the resistance, is the formula. In other words, volts is equal to the amps times the ohms. Now, some of you might be wondering, why on earth is current represented by the letter I? Well, I know it doesn't make a whole lot of sense for us. We would think that the letter C would be much more appropriate. But originally, current was also referred to as the intensity or the impetus of the flow of electrical charge. And so I got adopted at that point. And I is also used in other electrical formulas for a different unit that we'll be taking. Well, actually, we probably won't even touch on this year. That'll be for physics later on. But hopefully, the relationship does make sense when you think about it. If you want to have a lot of current, and depending on how much resistance there is, it's going to very much shape how much voltage or how much push there has to be for the electric charge to go through the circuit. So the voltage will get raised or lowered accordingly. If I increase or decrease my current, okay, I'm going to increase or decrease my resistance correspondingly, and vice versa. I can decrease my current in a circuit by increasing my resistance, or I could reverse that. I could lower my resistance and increase my current, depending on what it is I'm trying to accomplish. And that's going to be a valuable tool depending on what electrical device I'm happening to use. So if we look here, we got our formula, but you always remember, whenever you see a formula like that, it's really three formulas wrapped into one, just how we juggle them algebraically. If you happen to be looking for voltage, if I would just take this little triangle and I cover up the V, you see the I right next to the R, and you know that it should be I times R, or the current times resistance, how I initially introduced this to you. But if I was looking for the current, if I covered up the current, I'd see that it is the V over the R, or the voltage divided by the resistance. Well, if I'm looking for the resistance, you cover up the R in that little triangle, and you see that it is V over I, or the voltage divided by the current. Now, some of you probably are pretty handy with your algebra. You don't need this triangle, but if you find it helpful, you certainly are welcome to use it. Quick little practice problem or two. If I have a 2 amp current running through a circuit that has a resistance of 6 ohms, well, what's the voltage that's powering this circuit? Well, I look at my little triangle. I cover up my V. I know the solution should be voltage is equal to the current times the resistance. So now I'm going to take a look at the problem and figure out what numbers to plug into which places. For the current, I know the current is 2 amps. I know the resistance is 6 ohms. I plug those two in. I plug my numbers into my calculator, and voila, my voltage is 12 volts. One more problem to practice with. If I've got a circuit that has 5 amps of current running through it, and it's powered by a 120 volt outlet, what's the resistance in the circuit? Remember to look and see what it is you are trying to find as a solution. And this question is asking for the resistance. So if I look at my triangle, I cover up the letter R. I see that it should be, in order to solve it, V divided by I, V over I. Resistance is going to be equal to the voltage uh, divided by the current. I plug in my numbers. My voltage I see in the problem is 120 volts. The resistance is going to be equal to that divided by whatever the current is, which I see is 5 amps. Now I just do my math. 120 divided by 5, and I get my 24 ohms of resistance as an answer. So for today, we're going to practice using this formula a little bit. I know the math scares some people a little bit, but again, we're just going to be multiplying or dividing a couple numbers. The tricky thing comes in, well, which one do I multiply by, which one do I divide by, in which case, and so forth. But if you take your time through, read the problem, read what it's asking for, and then plug those numbers into that formula, we're all going to be able to do this. Now, there's a quick quiz on Schoology that's going to have these questions. I also put the questions. I also put a link to the problem solving questions on a separate sheet if you want to. Some people like to print it out and use a pencil paper to do it. That's just fine, and work it out that way. You're welcome to do that. But the only assignment is the quick quiz here on Schoology. Hope it all goes well, and we'll check back tomorrow.